September 2020. Scientists studying gravitational waves picked up the signal of an extreme event in the distant universe.
What researchers are looking for are things called gravitational waves. They're like ripples in space itself. Most signals sound a little bit like a chirp. It's a noise that's very characteristic. It goes a bit like sort of whoop. But this particular event was so extreme and so sudden, it just sounded more like a thud.
This faint thud from halfway across the universe is music to the ears of intermediate black hole hunters, because its pitch can mean only one thing.
This could only have been created by two really massive black holes colliding into each other and producing a combined black hole with a mass that's 142 times the mass of our sun. So that is, for the first time, getting into this intermediate mass black hole regime.
Now that we're certain intermediate black holes exist, could they help explain the origin of supermassive black holes in the early universe? In 2018, astronomers found a system called APEP, 8,000 light-years away, with two very massive stars, each one about as massive as Betelgeuse.
These are giant stars nearing the end of their lives with massive outer layers of gas that continually contract and heat up again and again.
They become really huge and bloated and swollen, and they're prone to huge outbursts.
These unstable stars are called Wolf-Rayet stars. They're very rare and so hot and bright, they emit more radiation than 1 million sun-like stars. This intense energy is blasting their outer layers off into space.
Mass loss has been occurring from the star, so much so that you've actually lost all the hydrogen that wasn't burned into helium. So now you have a star that's made entirely of helium and heavier elements.
With no hydrogen left, these massive stars are running low on usable fuel. They're like ticking time bombs, made even more dangerous because they're spinning so fast.
It's spinning so quickly, it's on the verge of ripping itself apart.
And this means that when this thing blows, it's gonna blow hard.
When a star goes supernova, its core collapses. The smaller it gets, the faster it spins. Some cores collapse into fast-spinning neutron stars. Heavier ones, like APEP, collapse into even denser and more mysterious objects. Black holes. The immense gravity within APEP's collapsing core will drag back some of the gas and dust into a spinning disk.
As the material falls onto the core, it compresses and it speeds up.
The dying star spins faster and faster as it collapses.
And this incredible rotation drives the creation of massive magnetic fields that are capable of funneling material around and up and out in the form of huge beams of radiation.
We're trying to understand if neutrinos are their own antiparticles. And if they are, that would explain a big chunk of what's missing from the current Big Bang theory.
Even though dark matter makes up nearly 85% of all matter in the universe, we don't really know much about it. What we do know is that it exists, based on the impact it makes on the universe.
We notice things like gravitational lensing, which is areas in the universe where we have intense gravity that actually bends light, according to Einstein's general theory of relativity, but we don't see the mass that's there in order to generate that gravity. We don't see what's actually bending the light.
Some researchers believe the leading candidate for a dark matter particle is a WIMP, or weakly interacting massive particle. Because WIMPs interact so weakly with ordinary matter, they are extremely hard to detect.
Even though we don't know what a WIMP is exactly, because we've never seen one, we do know, based on the properties that we've derived from what dark matter does in the universe, what that fingerprint should look like.
For billions of years, the Milky Way conquered galaxy after galaxy, tearing its smaller rivals to pieces. But our galaxy is about to meet its match.
In the not too distant future, galactically speaking, a much, much larger battle is due for the Milky Way.
A battle with a local superpower, the Andromeda Galaxy. We thought this huge galaxy might wound us in the future. Now, recent evidence reveals it's going to make a full-scale assault.
We've known for a long time that Andromeda is heading more or less toward us, but we didn't know exactly in what direction. But in recent years, we've been able to pinpoint this a lot better, and yeah, it's heading right for us.